Good afternoon, good evening, wherever you may be, and welcome back to Streaming Media Connect 2025, our 17th ever Streaming Media Connect, where this week it's all about live. I'm Steve Nathans Kelly, editor of Streaming Media and chair of Streaming Media Connect, and it is my pleasure to welcome you to our last session of the day, Benefits and Trade-offs of Adopting and Implementing Codecs. And before we get started, just a few housekeeping notes. We're going to do a giveaway at the end of this session, as we do in all of our sessions at Stream Media Connect. And the first person to correctly identify the artist and the track that you heard as we were coming in will win a $50 gift card from Amazon. You must be present to win, so stick around for the session, which is going to be great, and be here at the end, and you can collect your prize. So chat in the chat as always, and we will take questions at the end of the session. So put questions in the Q&A for the panel, and we'll get to as many as we can at the end. Closed captioning is available, so hit the CC button to turn that on. And sessions from all 3 days of Stream Media Connect are already appearing on the Stream Media Connect YouTube channel. There'll be a link in the chat for the playlist where those will appear. And we'll be back right here February 24th to 26th, 2026 for Streaming Media Connect 2026. And the website isn't open yet, but the call for speakers is. So if you have an idea for a session or you want to speak, join a panel, moderate a panel, whatever, let us know in the call for speakers. I'll be putting together the program over the next week or so. I think that's about it for my opening remarks. So without further ado, I would like to welcome Streaming Media contributing editor Jan Ozer to the stage. Are you there, Jan?
I'm here, Steve. Thank you.
Hey, can you turn on your camera? Great. All right, good to see you. Take it away.
Okay, thanks everybody for coming. This is our panel on implementing codecs, the benefits and trade-offs of adopting and implementing codecs. We've got two speakers who have actually implemented codecs in the recent past, and then we've got Alex Davis, who's an analyst. Let me cover the two implementers first. It's Hassene Tmar, who's technical program manager at Meta, and then Behnam Kakavand, who's video R&D lead engineer at Evolution Gaming, who just implemented a live SVT AV1 driven AV1 implementation, which I'm pretty excited to hear about. Alex Davies is editor and senior analyst at Rethink TV. They've just introduced a new report, an update on it's the Media and Entertainment Video Codecs Report, a forecast for 2025 and 2030. I'm smiling because the first time we saw the report, it was 2020 to 2030. And a lot of things have changed in those intervening 5 years. So interested to hear from all of them about what they've done and what they've learned. Let me kick it off with you, Behnam. Tell us a little bit about where you are with AV1, what you've done, and what you found in your initial implementations of it.
Hi, Jan. First of all, thanks for having me. Yeah, as you said, I'm a video R&D lead engineer with Evolution. We are in the business of live casinos, so low latency live streaming is our thing. We are delivering video with AVC as so many others, and as of today and very recently, we added the AV1 to our settings, and we are encoding in software on prem. As you said, for AV1 we are using the SVT AV1's version 3.1.2, which is the latest release thanks to Hassane's team, and X2644 for the AVC.
Okay. Any initial findings from your implementation?
Yes, the surprising thing is that actually what surprised us that a very big number of users actually can use AV1 today. And as of now, we are delivering AV1 just to the users with mobile, with hardware decoding capabilities. And to our surprise, and some of our streams, we are delivering it on a limited number of our streams. But on some of those streams, the majority of playbacks are actually happening in AV1, which was a surprise. We didn't expect that.
Okay. Any preliminary information on how the data rates for AV1 compare to H.264?
Right. Given our use case of low latency streaming and the need for fast encoding, actually, as of now, we don't tune our encoders for lowest bit rates possible, but we are tuning for comparable quality. And right now we are getting that comparable quality with similar and in some cases even slightly higher bit rates compared to the current H.264 streams. So we are not aiming for bandwidth saving right now. We are aiming for gathering real world stats on playback and the number of players actually can receive and play the video in AV1. So yeah, so no information on savings as of now.
Okay. And how long has the implementation been up and running?
Well, a couple of months, 2.5 months, around something like that. We are
Okay.
gradually increasing the number of streams, the number of live streams that will have this setup in them.
Okay, real quickly, how did you take that live for the first time? Did you enable one channel or all your channels, or how did you decide to do that?
Right. We started by implementing it on one of our relatively simpler channels. So we rolled out with one channel. So we wanted to first evaluate the encoder capabilities, the amount of uh, resources, overheads that will be imposed on the encoder side of the thing. And that's why we chose relatively simpler type of streams and rolled it out, watched it, see how playback basically it goes on. And yeah, to our surprise, uh, nothing bad happened. I wouldn't say that anything good happened, anything better, but I'd say that's not a bad news when you don't see much changes in increased number of errors or things like number of playbacks didn't this playback stalls didn't increase, the length of playback didn't change, so that was not entirely bad news. So I guess that if you're delivering at exact same bit rate or slightly higher than that, you expect something like that. So I would say that still the jury is out on how it will roll out, how which other streams are receiving it, but we are aiming to implementing it on some of our other high visibility and more complex type of streams that are having a couple of thousands of or tens of thousands of users, concurrent users, and then see how it will play out.
Okay, and just for people who are unfamiliar with evolution, I should have asked you this before. You're gambling, is it? You're not computer gaming. You're more gambling, casino.
Yes, yeah,
So
exactly. Yes, live casino.
what is an easy channel? Is it poker or 21 as opposed to, the wheel thingy?
Right. Yeah, I mean, th things like blackjacks or pokers, yeah, any of those card games are pretty simple. They almost look like talking head kind of streams. Nothing, no big movements, no big small details, stuff like that. So, but some of our other more complex type of streams are things like we would like to call them game shows. They have multiple different rounds with animated and real world streams combined and lots of movements and shining and explosions and all of these things happening. So those are the more challenging ones that are receiving the AV1 next.
Okay, thank you. Hassan, you
Sure.
want to turn on your camera and your microphone and join us?
All
Hey,
right.
why don't you tell us a little bit about what Meta is doing with AV1?
Hmm. Cool. Yeah. Thank you for having me as well. My name is Hassene. I'm a TPM at Meta. Um, we at Meta we started pushing AV1 in VOD on Reels since 2021, 2022 timeframe. Our first tech engineering tech blog is out there, so you could see the difference between that one and the most recent one. And we started with iOS, where we pushed AV1 decoding in software at the time, with an awesome open source library called libdavid, or DAV1D, and using the SVT-AV1 open source encoder on the software side. We deployed what's AV1 and what we refer to as our premium encoding. And so basically to make that clear, so videos that get uploaded to Meta, depending on their viewership, if it's uploaded only if it's viewed only by a small number of viewers, then they get the basic encoding because their cost of distribution is not too high. If they're viewed by so many, like maybe thousands or millions of people, Then they get what's called a premium encoding, where we maintain a good quality and reduce the bitrate so that we get a much better, much faster distribution. And AV1 is done on the latter piece, and it's basically done in software. What we're seeing out of AV1 is pretty awesome. So initially, we pushed AV1 as a quality boosting tool. And we quickly found out that it really depends on the user's needs. So some of our users like quality and appreciate quality more, especially in North America with the high-end phones and things like that. Some others need video when they cannot see video, and so they appreciate that bitrate reduction so that they can literally get the video, especially with the very low bandwidth networks. And the rest is kind of somewhere in between. So we don't really have a flat number on bitrate savings because it's tuned differently for different apps, different surfaces, different regions, depending on the needs of the users for those regions. But our blog showed that we saw in some content when you use the AV1 screen sharing tool, you can go up to maybe even 60% on top of even VP9 in that space. And so very great results. And nowadays, happy to say that AV1 covers about 70% of all of Meta's watch, which means that, doing simple math, if we have about 3 billion users, every daily active user watches 1 minute of video per day, that's 70% of 3 billion minutes of video, basically.
Okay. Is that still Reels or is that the entire catalog of
No,
Meta?
yeah, it's pretty much everything now. So real stories, feed, every on the video on demand space, basically, mostly.
What about live video? What's your take on when that will happen?
Right. So, um, I don't really have a line of sight for live per se as the kind of broadcasting live or the sports live, but we're going all the way the other end right now with video calling, and we're seeing great results for AV1 on video calling as well. So today with Messenger, you're probably using AV1 in some space or the other, especially with its screen sharing tools and lower bitrate. It allows calls to be much smoother, less freezes, less jitters, longer calls. So all of those are benefits that we are seeing, and hopefully soon enough we're gonna publish the latest and greatest results on that. They're not public yet, so unfortunately I cannot give you all of those numbers, but we promise to get out with some good description on what we're doing there and what we're seeing. But overall, great benefits for the users.
Okay, and let me brag a bit for you. You've been one of the primary developers of SVT AV1 for a while, and as I understand it, you just won a big award from the Academy, huh? You want to tell us about that?
Right. So to be fair, I wasn't one of the big developers. I'm the software maintainer, so I've been doing more of program management. SVT AV1 has an army of awesome developers from different companies, Intel, now VLIT, and a lot of few ARM is doing a great job at optimizing the encoder for ARM. We get multiple, contributions from AOM members. We also ported code from libaom, and so the conformant parts, and so we gotta give credit to libaom as well. Actually, SVT-AV1 uh, won recently the IBC Innovation Award for its work on the fast decode mode. This is basically a mode that makes the encoder optimization decoder aware. And as such, we make sure that the bit streams that we are generating are actually easier for the software decoder to decode. And this is what allowed us to actually target a lot of devices now, like a less than $100 device, Android device can play and decode the 720p AV1 stream, which is pretty awesome. Now, what got the prestigious Emmy Award is AV1 as a whole, as a standard, and the Alliance for Open Media got that with leading contributions from our colleagues at Google, Mozilla, Cisco, Intel, and a few folks, and we're happy for both. It's a great effort, of course, with SVT AV1 and the rest of the AV1 productization effort at Meta being a great testament of how successful the standard is.
Congratulations. So
Thank you.
Alex, let me wake you up now. You've had a big birth recently as well with your report. Why don't you tell us about the report, how it was created, who it's for, and what the basic value proposition is?
Absolutely. Cheers, Jan. So yeah, it's part of Rethink TV, which is our sort of research subscription service. You can check that out at rethinkresearch.biz, but there's also the great article done by Jan on streamingmedia.com, which yeah, I'll save a lot of the details for that. I'd say go and watch that. But yes, the report is an update, and we first put this together in 2021 and then updated near end of 2023. And last time round, we were all very optimistic about VVC. So the hope that there would be a big launch, a big push out. But no, the sort of short answer is that hasn't happened. And so yeah, that is to AV1's benefit. There's a lot of background politics going on, and patents and things. And I've been told like, hey, let's stay away from that. So I shall. I won't put my foot in it. But this report is a look at the install base of video devices that are, sold per year, still in use in a year, and then still out in the market. And that spans everything from dumb TVs all the way to smartphones and tablets. And as Hassene was saying, there's a surprising amount of AV1 usage now because AV1 support has been proliferating through the market. So yeah, this report charts at the high level like our expected usage rate on the decode side of things in that install base of devices through the period. And the new thing that everyone should pay attention to are the two streaming pools. So the Access Advanced VDP and then Advanced Video. So that's the new thing this time around, because unfortunately it doesn't look like VVC is the new thing still.
And you're still, the word nobody has mentioned up till now is HEVC. So I mean, your projections show H.264 still in the lead in 2025, but HEVC a clear second, and I guess AV1 a pretty clear third at this point.
Yeah. The sort of the gradual decline of AVC is kind of tied into the age of the install base, the sort of average age of device. And generally, larger screen devices hang around a lot longer. And through our kind of pay TV operator and like telco focus, where we're forecasting those services, the kind of legacy devices are still going to pull AVC and HEVC, but on the more fast moving smartphone, tablet, PC kind of angle, that's where AV1 hardware decode support like surges forward. And if your video workflow is set up to choose the best available hardware decoder, there's a very good chance if you're in the kind of web and app world that these days AV1 is that option. But that's the kind of shift. And yeah, the AVC decline, like that switch over generally has got earlier every time we've updated this forecast. So the first time around we thought it would be nearer 2030, but for now it's kind of 2028 or so. That's when HEVC comes in. And then yeah, this time around, because VVC has been so sort of far off the historical normal anticipated pace, that means that yeah, AV1 tracks up a lot quicker than we thought.
Okay, who did you speak to form these projections? Was it, I guess, IP people? I mean, IC developers? Was it device manufacturers? Did you speak to any software publishers?
It's a bit of everyone. This time around, though, was notable for all of the patent pools speaking to us. But generally, I'm chatting to people all through the year. And yeah, it's a good blend of video services, of operators, of device makers. Sometimes it's more like CDN types as well because they've got something of a view of this. But yeah, a good spread.
Who's the target for the report? Who do you expect the buyers to be, and what's the value proposition to them?
Generally, subscribers are found across like devices, services, operators. This report, the codec, is always popular with licensors because it's charting the expected like royalty markets. But at the same time, that's also why it's popular among the hardware providers and the sort of semiconductor silicon side of things too. The operators they find it useful because they want to know what sort of device footprint they have to support. But yeah, Rethink TV covers a lot of other things, so it's one of these things where if you read all the reports, then the sort of value increases, I guess. But this one is pretty tightly focused on devices and then anticipated royalties from devices.
Okay. Behnam, let's switch back to you. What work did you do to decide to implement AV1 as compared to HEVC or any other codec, VP9 or anything else that might be out there?
Right. First of all, we thought that everyone came later than HEVC will last longer as well. So we decided to go for the latest and greatest, of course. For our testing, we did rounds and rounds of testing of almost every available encoder out there, hardware and software, and then landed on SVT AV1 for so many reasons. Not all of them are technical, but financial as well. I mean, imagine for 2,000 live channels, if you want to buy hardware encoders, it's not very feasible, and the scale of the things put some restriction on us. So that's why we decided to start testing and going with the software to keep up with the current workflow and settings we already have in place, which has always been software based. And so, yeah, we did rounds and rounds of testing. We even developed our own genetic algorithm and reinforcement learning applications to automate the testing, make use of some automation to speed up the testing of different codecs, find out what is the optimal codec settings and parameter sets to use to get what we want. And we found out that actually, due to this testing, we found out that this fast decode setting that Hassene was talking about has, of course, a big impact on the speed of encoding as well. And the fast decode 2 actually helped us to minimize the latency on the encoder side as well, making it feasible for our use case as well. So yeah, testing and on playback side, you could say that it is right now in testing mode and on the playback side. So far, we never had enough real world information on live streaming AV1 before. Nobody has provided such information. So it's on us to basically test it and see how it works. So now I would say testing is the biggest thing that we've done and we continue to do.
Tell us more about the hardware versus software. I worked a while for NetInt. I know that hardware
Right.
AV1 is available from AMD, it's available from NetInt, it's available from NVIDIA.
Right.
Why do you think software is a better way to go than hardware?
Well, I would say that it's better for us. I wouldn't say it's better. But the thing is, I mean, some of our competition, even as of today, are using NetInt devices for AV1 encoding as well. Very recently, actually, so we heard. But the thing is that for us, being able to replicate the setup anywhere in the world, in a new studio, in a new continent, as it happens, and doing it very fast, it's not very easy to do it with the hardware encoder. You have to provision things, you have to order these devices, and they are not always readily available if when you need them. So software is the easiest way to replicate the same identical setup everywhere in the world as we need it. So that's why. Performance-wise, I'm sure they are great. I haven't tested the latest NetInt devices in a long time. I know that there's been some development, but at the initial time when we tested it, the per frame encoding time was too long, so it was not very feasible for us to use it at that time. That was another reason, but it might have changed.
Okay. Hassene, is that question even relevant? I mean, were you guys were an original contributor to AV1? Was it you never, I think, really was HEVC ever in the picture from a consideration perspective, or was it we're going to do, if we had a codec, it's going to be AV1 all the way?
Well, we followed science, right? So we did those famous graphs that we keep publishing at SPIE papers and so on, where we compare we wanted to put into perspective both compression efficiency and compute. Because in a scale like meta, compute does matter. Things get really expensive very, 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 very quickly. And as such, we drew all of the codecs we do, AVC, VP9, HEVC, AV1. And we've been happily surprised that AV1 can cover the whole range. And not only that, it actually gives you that additional compression efficiency boost on top of HEVC. Of course, there's been some other high level issues with HEVC, but we've decided to take that starting point, and with AV1 with newer features, also scalable towards things like screen coding tools, and it gives us even ability to do film grain if need be, and at the time specifically, it gives us some quite it gives us more options basically. Let's put it this way. So we started with that, and then we found out that AV1 can give us a nice compression efficiency boost at the same complexity, and that's what we cared about to start with. And so we took that, and that was the encode side of it. Now on the decode side, it was a lot more complex. Unfortunately, we cater to a very wide variety of devices, pretty much mostly mobile devices. And so what we did is we partnered with ATM, and then we showcased a report where we generated some bit streams with AV1, what we referred to in that report as tools on, tools off. We picked the tools in AV1 that are most complex to be decoded in a software decoder, and then we turned them off. And then we ran this over a very large lab of devices that ATM has, and it like about 500-600 devices now. And then we did that analysis. We produced a big report to show that on many of these devices, we are able to achieve at least a 540p or 720p 30 basically speed for decoders. And that was the starting point. Once we saw that was good enough, basically proof that AV1 is ready for prime time. And then we started, pushing and expanding the coverage bit by bit until we get to the point where we needed a much better fast decode as compared to turning tools off, so that we don't lose a lot of compression efficiency. And we started expanding into the Android ecosystem, which was quite a significant challenge, actually. The blog that I'm referring to actually tackles that in particular, and how we and would like to be very transparent and help others to do the same, how we actually were able to decide which device can actually get AV1 and which doesn't. So we followed some benchmarking, and we basically take the specifications of the device, and based on that we do like an if else tree. And the nice thing about it is if a user upgrades their device, they automatically get AV1. We don't have to re-benchmark that design or anything. It's a dynamic way of delivering AV1 to them.
So you're describing an internal tool that benchmarks every viewer. Is that?
We don't really benchmark every viewer. We just look up the specification of that device, and then if it has enough cores, enough memory, enough things like that, we believe it's ready to decode AV1. It's a simple if-else kind of tree that we will share publicly. It's nothing secret in that space.
Okay. Alex, this is a good jumping off point for you. I mean, my experience has been that beyond Meta and Netflix and YouTube, which are enormous companies and obviously deliver a ton of streams, there's not a lot of real world adoption of AV1. What did you find, and how much of that relates to the reluctance to go to a software decode as opposed to hardware on the mobile side?
Yeah, there's a very long tail of HEVC and AVC that stems from device viewing through TVs, essentially TVs and set tops, and even connected Blu-ray players and games consoles, like all of that stuff, which is still out there. And especially with lots of these very cheap streaming dongles, that ecosystem is still responsible for the majority of hours of OTT viewing. There's kind of existential questions of viewing on a TV, whether that's broadcast or over the top, but that's a kind of backdrop that is it kind of means that if you're deploying a video service that is going to be on a large screen, you can very safely bet that there's HEVC there. And so my view is that you should prioritize HEVC. And that won't change for many, many years because those devices are refreshed, like they're replaced by consumers slowly. And similarly, the primary viewing device will become a secondary device. It'll move into a kid's bedroom. It will go into a garage, an office, that sort of thing. They're generally only thrown out when they break. Is a decent rule of thumb. On mobile, the time that a device is used has increased, and since COVID, really, it has jumped up noticeably. We're well past the carrier supported 1 year life cycle. It's more like 2 to 3. But similarly, like we know that AV1 has been available in devices for a long time now. So if you're deploying to mobile, and especially if you can deploy your own application, you've got a pretty good chance of using AV1. But at the same time, like HEVC is probably there for you as well. So if you're a video service, you've got to make a decision there on what you want to support. And I think the separate piece here is the sort of available bandwidth. The graph is available in that streaming media article, but it kind of charts the kind of required bandwidth for a given resolution, 720 through to 2160p, 30. And the point that I make there is that we kind of passed the required bandwidth ages ago, as early as like 2014, I think, in mobile, and it's much earlier in fixed. It's sort of 2011, 2012. So there's a lot of bandwidth. So it's not necessarily that bandwidth is the driver on that front, like it would have been with HEVC and AVC historically. That is part of why I think VVC is slower. But yeah, AV1 in mobile is great. It's just that its mobile consumption is dominated by a few very big apps. So the mobile long tail is kind of different. It is different and it's a bit difficult to project, whereas like large screen viewing is a bit easier.
But even, I mean, you didn't really address the question about who's using AV1, or did you get that information, or you just forgot that I had?
No, AV1 is generally favored by AOM members, right? Don't want to go too far into patent disputes and things, but it's a response to the existing market. So it's an attempt to break from the sort of the MPEG norm, and there is a bit of a divide. And then like future looking is there'll be more AV1 usage from others because the device availability there and the sort of the news, the reports that come out from like the likes of Meta and Netflix that are showing strong AV1 usage, strong AV1 kind of performance, and then trickle down, I suppose, is how you would describe it. It'll move through other elements of the video industry. So yeah, at the minute it's still dominated by a handful of very big, very powerful companies, but
And
it will proliferate.
and they're, I mean, they move the needle in terms of the number of total streams delivered. So it's a big number. What do
Yeah.
you, is VVC geographically oriented when it comes to usage versus non-usage?
At the minute, it seems more popular with Chinese outlets, but at the same time, there's a whole geopolitical story to tell there, where Europe is being squeezed between America and China, and yeah, Chinese licensors are more common in VVC than they were in HEVC and AVC. The point I always love to bring up is Qualcomm still hasn't put VVC in its Snapdragon line, but 2026 we should have Huawei's flagships with VVC, so like hardware VVC decode. So that will be a pretty notable event. But at the minute, VVC only really pops up in software decoding sort of demonstrations, and it's usually around IBC. Last 2 or 3 years, it's cropped up. You know, Qualcomm goes, "Hey, we can do VVC in software," and you're like, "That's very cool, Qualcomm," but no one seems to be using it for a service.
Okay. Hassan, one of the early questions about AV1 was encoding time. And when I first looked at it for streaming media, I think back in 2019, it was 5,000 to 1 real time. And I know that SVT AV1 has cured a lot of those problems, but talk to us about the relative encoding time for SVT AV1 versus X.264 and how you see that translating to live. You kind of touched that in a little bit, but it's working live for other vendors. And live is obviously a big piece of what Meta's doing, as well as YouTube. So, just interested to hear when you think it'll break in there.
Yeah, so again, I'm gonna point to what we published recently. I think the most recent graph that we published was about a year ago or so, where we could see that SVT AV1 from a complexity point of view kind of matches about the same level as X265 and then surpasses it going into the AVC land in that space where it still maintains a significant quality or compression efficiency boost. Now, it's important to state that that is in a specific set of testing conditions, which is the convex Hall encoding, which we use at Meta. But at the same time, the power of SVT AV1 is to be able to kind of quickly turn from a VOD state into a live state using loss like a multi-threading without any loss in compression efficiency, which is quite a unique feature for SVT AV1. And taking that into perspective, you would be able to take an SVT AV1, even M5 today, and be able to run a live stream on a basically even a laptop probably nowadays. Don't quote me on that, Jan. I know that you would do, but but basically that's it's the idea here is if we focus on cycles when it comes to complexity and assuming the implementation has a good enough multi-threading, the cycles comparisons would translate very nicely into live at this point. Answering your second question is, again, we don't have any plans right now for AV1 on live. Um, Simply put, because not min or sorry, not most of our watch is on the VOD, not much of it is on live. And as such, we would give like we still see that AV1 could even benefit further in terms of VOD, more compression efficiency, going to even slightly slower presets now that they're getting really fast with SVT AV1 still bringing us more compute efficiency. And that is for our users much better than life at this point. Now, it's important to note that at Meta, after you finish a live stream in a Meta app, then you get something called the WAS life, which is basically a VOD rendering of the same life. And we see a lot of fetch on that, more than the life itself, basically, which kind of covers that little gap in there.
Okay. Behnam, what are you seeing? What's the basic machine you're using for live at this point? What can you tell us about cores or speed or anything that can help people understand the kind of computer? I mean, Hassane's already said it can be on a laptop. But what's
Right.
your, what can you tell us about what you found?
Yeah, we certainly don't do our lives on laptops, of course, but they're always on Xeon, Intel CPUs, basically. With all the AVXs, all the latest and greatest features for us. I mean, doing low latency live, we tested with older generation CPUs, and they could not just keep up with our requirement, which is to roughly below 100 milliseconds of encoder latency. But with the latest, I can give you an example of one of the CPUs that we are using. It's right in front of me, actually. It's an Intel Xeon Gold 5120 CPU, 2.2 gigahertz, and it's around for 56 cores on that machine. So this is an example of one of the machines that we are using for it. I must say that on a very large number of our machines, which are more than a decade old, and they haven't been turned off since 2015, 2014, something like that. And those machines were actually not capable of doing AV1 side by side when you are doing it right. Do the AVC, like 4 different ABR ladders for 4 different live streams, adding AV1 to that, it was just too much. So we are just keeping it on the latest and greatest machines. Anything later than 2022 models, probably, we are just using it on those kind of machines.
So what's that look like when so you got a 50x core machine? Is that doing one input to one ladder or multiple inputs to multiple ladders?
Yeah, there are generally multiple inputs, at least 4, sometimes even more, and each of which has ladders. The number of qualities on each ladder is varied between 4 and 5 different qualities, and we are currently doing AV1 in all qualities. Versus if I can imagine if you're just keeping it to HD and 720, of course that will remove a lot of overhead. And technically, AV1 in live mode is not very good for lower resolutions. I mean, you will see the best results for not good is not the exact description that I meant for. I mean that you will get the best results on the higher resolution compared to the lower ones. So yeah, in our case, we are doing all the qualities. One reason for that is that we first try to get the playback. I mean, having all the qualities and all the resolutions on AVC, but keep the AV1 resolution just to the highest 2 resolutions. But what we've seen that when we're switching from AVC to the AV1, we've seen users would see a black frame, which is not very good. So, of course, we could do some trickery there. We might be able to receive both qualities and start decoding in the background and switch and all of these kind of stuff to switch seamlessly, but we haven't get around to do it, implement or test with that thing. So right now it's AV1 and AVC on all qualities on these machines.
Okay. Are you doing combined encoding or transcoding 264 and AV1 on the same machine in the same encode? So you've got
in the same command, yes, they are on the same command line. Yes, we want these streams to be in sync as much as possible. I mean, you see that there's an element of interaction on our games between the players and the game presenters and the game itself. So time matters, and we wanted to keep everything in sync. Of course, there are other ways to do that. We already are having in sync on different machines in streams. We are doing some timekeeping and time stamping to make everything in sync. But in this case, we wanted to get it out as soon as possible. So we didn't do any of those things. We are just encoding it in the same command.
Okay. What did the player testing look like? How much budget of time and expense did you incorporate into that, and how was it enough, or what did you take from the whole QC experience on the playback side?
Right. I would say that right now our rolling out of AV1 is kind of our QC process, and it is just going out. There has never been a dedicated lengthy live test on different machines and with different players. So that's why we've been a bit cautious to rolling it out. That's why we haven't rolled it out on all tables on our live stream. So we started just by providing everyone to the users with on mobile devices with hardware decoding capability, and gradually increased it. I mean, turn it on, waited a couple of days, and then turn it back off, and then things like that. It was on and off thing, and so once we were confident that there is no impact on user base, then we just turned it on and left it on. So yeah, I wouldn't say that there was a very dedicated budgeting for QC and stuff like that. But right now we are just watching these stats and see how it plays out.
On the encoding side, was it just adding? I mean, are you FFmpeg based or something similar to that? So
Yes,
was it just adding more outputs that had AV1?
right,
Was that
right,
so?
right.
That's a couple of hours of work, and then you're ready to go. I mean,
Exactly,
I'm not trying to
right.
minimize it to anybody watching,
Yeah.
but
I mean, yeah, it is kind of sort of like that. We are just muxing everything into single streams I mean, delivering on the back end until the edge servers. So yeah, it was just matter of adding it to a machine on a test machine first, of course, to see which machine can keep up with it, then rolling it out on our live production machines.
okay. And we have a question coming in from the audience. Probably best for us then is there a happy medium for now for how much battery life versus CPU power you sacrifice well, let me read the question accurately because I'm not sure I just did and I was focused on a different issue. But is there a happy medium for how much battery life slash CPU power to sacrifice for given bit rate reduction? I guess that's looking more on the encoding side than on the playback side. But I know those charts that you've talked about have really tried to focus on the CPU versus quality equation. So why don't you comment on quality versus CPU?
Yeah, not really sure how to answer that question because with the way we look at it at Meta is we run a test, we give AV1 to a certain set of users, and we look at a variety of metrics. For example, their scroll performance, their freezes, their frame drops, things like that. And then how much they continue to watch the video. If they stopped watching the video, uh, probably because they see their battery going down or not, then we basically don't give AV1 to that phone, and vice versa. Like we're seeing that users are less sensitive to the battery usage. First of all, I don't think we're seeing a significant battery usage to the point that it's going to heat up the phone or something like that with AV1. So that's one to start with. And when the battery level is very low, we try not to use software decoding whatsoever on any codec. And so we default to the the highest possible level of hardware decode, and we stop there as much as possible. We lower the resolution as well. There's a bunch of ABR optimizations in that space, but at the same time, like we don't really have a I would say a function that maps battery usage to bitrate efficiency more so than more like a quality of experience in general towards a battery efficiency. And again, it's not only battery, it's not only compression efficiency here, it's also quality. And so some people are not going to care too much about their their metrics as long as they're getting really better quality. We see this more often on Instagram, for example, where users really like higher quality. The more you give them, the more they like it, even if it consumes a little bit more battery or drops one or two of the other metrics.
Okay. Alex, one of the with AV2 coming out by the end of this year, what did you learn from the lack of VVC implementation, and what drives codec implementations at this point? And how does that reflect on where you think AV2 is going to go and how quickly?
Yeah, the AV2 spec being finalized this year implies that it'll start turning up in silicon in 2 to 3 years. The Again, because it'll be favored in mobile, that should mean like it arrives quicker. The VVC angle is, yeah, it's not here yet. It will eventually turn up. It will be used in like large screen applications, but it's not something that kind of is being called for by the market. The Maybe building what Hassene was saying, the kind of software versus hardware element, like with something like VEC, like it's much more compute intense to do that rather than rely on like an old HEVC hardware decoder that you could almost bet your house is on that device if it's got VVC. So that uptake is yeah, it's going to be very slow on VVC. Whereas I think the AV2 adoption should be quicker. But again, that same kind of dynamic exists where if you were like driving towards doing AV2 in software, well, that device at that point is almost certainly going to have AV1 in hardware. So from the kind of compression or power metric that you want to prioritize, you're probably going to favor AV1 hardware rather than AV2 software. That I can't guarantee that, but there's lots of different trade-offs. And I think the other thing to consider at that point is the sort of resolution of the smartphone, like pushing more than, I mean, yeah, this is all very subjective, but pushing more than say 5 megabit per second to a smartphone is probably a waste of effort because like the visual quality, the discernible like subjective visual quality from the user, just they won't pick up on it. And maybe I don't think many of them are going to pick up on watching this specific channel or this specific app has drained my battery. I think a lot of smartphone users, given the age of the average age of the device increasing, there's an almost expectation that the battery life is just trash these days because it's just an old phone. So I don't know. There's lots of moving parts there.
Okay, so for software publishers watching this, for 2026, 2027, what should they be thinking about from a codec usage perspective?
If mobile, you've got AV1 in hardware, and you'll definitely have HEVC. It's more there about your kind of control of the app. The sort of mobile browser is a bit different. If it's large screen, yeah, AV1 in large screen is further away, but it's quite common. I think Netflix recently said upwards of like 80% of new devices they certified had AV1 in hardware. So like that's changing. It's just that if you're a video service that wants to appear on all smart TVs, you can't choose AV1. You've got to go with HEVC, and that's just a pragmatic decision because of the sort of silicon choices that were made, 5 to 10 years ago. We're still supporting those devices.
Okay. So wrapping up, Behnam, what are your projections for AV1 rolling out in Evolution Gaming, and what can you advise people who are considering AV1 for your type of low latency, real-time interactive application?
Right. I would highly advise to start at least experimenting with it. We are kind of sure that it will get to a point, the encoder implementation will get to a point that it will be fast enough, good enough, there will be enough savings, bitrate saving to roll out and see the actual benefits on the bandwidth side of the things. There are other factors as well. For example, if you're thinking like things like HDR, it's much easier to do it with AV1 compared to the AVC. And yeah, I would highly advise to start dealing with it. And just to going back to the question before regarding the sacrifice in battery, I would say that we are in evolution very sensitive towards this thing. I mean, the length of playback is very important for us, and we haven't seen any drawback, any drop in the length of playback for the users who are actually consuming AV1. Of course, they are using it on hardware decoders, but we are confident that it's gonna get better. Probably some similar situation will be with the software decoder as well, but we have to experiment and see, get the actual results on that. So it looks like that it will not affect by much to confirm what Hassene is saying, at least on the live side of the thing. So my advice is to start experimenting with it. The deployment of the new codec is not an easy task. It will take time. So the sooner you start, the better.
What's your ultimate goal in terms of bitrate savings with AV1? Is there one, or are you happy to just deliver better quality at the same bitrate as AVC?
Well, of course, with the amount of traffic that we are delivering right now, any savings, let's say 10%, 15% of saving would be big amount annually on the budget side of the thing. And if it will help reduce the number of playback stalls and errors on the user side, help with the extending the playback time, that's another revenue stream for us as well. So yeah, our goal is to at first save the bits, and some other games that are coming, they are pretty complex, they're very flashy. We would love to be able to deliver good quality with reasonable bit rates, not delivering 15 megabits to a device to get flawless playback.
Okay.
And we think AV1 will help us with that for sure.
Hassene, any thoughts you can share with us on AV2? You know, what that's going to have that's going to make software publishers want to use it more quickly?
I mean, beyond the additional compression efficiency, I see some really cool tools around multi-view and things like that. Those, it goes beyond the codec, it goes into the application-specific land, which I think is really helpful, especially for ads, for example, overlapping or things like that. I've seen a lot of these demos at, IBC this year. But in general, I mean, the team is kind of wrapping up as fast as they can and as good as it should be. And so hopefully we get something really awesome to deal with.
Closing up, what do you see as what has AV1 delivered to Meta over AVC? So AVC is an existing codec. You've implemented AV1. Is it longer viewing? Is it lower bit rate? What's your sense of the value proposition that AV1 has delivered for your company?
It's really all of the above. Basically, first of all, AV1 came in where we had VP9 to be pretty much in most of the watch, beyond AVC. And now AV1 is we see the benefit to the users. It's again, as I mentioned at the beginning, lower bit rates in some regions allowed people to watch videos where they could not watch videos, they could not load the video. Higher quality in some cases allowed our creators to showcase awesome content with really, really high quality. Allowed us to do, things like HDR, although we could do it with VP9 as well. The latest blog that came out, we're doing now Dolby Vision with AV1 on Instagram, and that's looking really good, especially on iOS devices to adapt for brightness and things like that. So, for the users, the quality of experience has increased significantly. We keep track of that, and the metrics just keep trending up. So it is definitely a successful codec for Meta. I think one key thing that AV1 or we've done well with AV1 was to support the ecosystem well enough with open source offering. This doesn't mean that, other companies providing, solutions in the closed source are not important. They are. But having a strong foundation for a good encoder, good decoder to start with is really a significant boost, and we could not have done it without it.
Okay, we got a late question in. Let me direct this one to Behnam. With AV1, will AV1 likely also help with latency issues and improving that aspect of delivery? You've talked about the fact that AV1. So answer that question.
Yeah, sure. We've seen that everyone implemented it in some vendor provided encoders like Visioneer, for example. They have this specific RTC mode for their AV1 encoder, which help to keep the latency as low as possible while delivering really good bitrate savings there. But I wouldn't say that the codec itself is just one leg of the latency. There are so many other aspects to it as well, like distribution side, playback side, and last mile. All of this stuff will affect it. AV1 is just one side of the thing. It's the encoder and the encoder implementation, hardware decoder, encoder, hardware versus software encoder. These are all playing factors into it. So I wouldn't say AV1 in itself will affect, has a big thing to say on the latency side of the thing is, but it definitely is a factor. Hope that answered it.
Okay, Steve, you want to close up and thank everybody, or should I?
You're on mute.
Since you're muted, I'll do it. Listen, Hassene and Behnam and Alex, particularly you, I know it's late where you are. I really appreciate you guys sharing your stories and sharing your experiences. It's very new to me and very interesting to me. AV1 has really come a long way. I've been speaking to Behnam, I think has talked on 3 of these panels, and each time it was planning, and now he's finally implementing and gotten really good results. So it was really wonderful for you guys to share your experiences with us and Alex, the fruits of your research. And I appreciate you taking the time and sharing.
Yeah, thanks everyone.
Jen.
I'm proud to be the
Thank
one
you.
person who tried to speak while on mute today. So this has been great. And just to close up, we do have a winner for our Amazon gift card. We had one person who was really close, and then somebody got it perfectly. So congratulations to Mike Latta, who correctly identified Louis Armstrong and Skokian. And we will be back tomorrow at 10 a.m. Eastern Time, 7 a.m. Pacific for our late-breaking keynote with Neil Roberts on delivering optimal global live sports streaming. And that'll be Warner Brothers Discovery's Neil Roberts and the one and only Andy Beach. So I hope to see you all then. Thank you.
Thanks again.
Thank you.
Thanks, everybody.